We can survive about 30 days without food, 3 days without water, but I promise you, give it 3 minutes, you're out of air. Hi, I'm Darren Bibby, and I want to talk to you today about air, and more specifically, clean air. 30 years ago, I started AirCure with a simple idea to remove secondhand cigarette smoke. At the time, it's hard to look back and think that in public places you could still smoke, and in the workplace you could smoke at your desk. In fact, a lot of the presentations that I did in the early days, someone would light up and go, "But what's wrong with cigarette smoke?" So we moved from cigarette smoke, we moved into asthma, we then went down the mines solving silicosis, and eventually we landed up in air pollution control. So we've stayed within the clean air solutions business. The problems have just got a lot bigger. Air pollution is an inevitable consequence of industrialization. And while we're demanding electricity, cars, houses, food, we are essentially asking for more and more, which is going to create more and more pollution. So while we are demanding, they are going to be supplying. So we need to be creative. We help industry to comply to air pollution regulations, and there's a legal compliance that we would like to help companies achieve. But there's a far greater reason for doing this, and that is our moral obligation to the next generation. We have a phrase called blue skies for future generations, and that's possibly the best reason of all. With regards to air pollution, if I go down to the basics, we need to understand that there's two components that are in the smoke that comes out of those industrial chimneys. Is you have particulate matter and then you have the gases. Now, a lot of people are brandishing these terms around like global warming, climate change, greenhouse gases, and carbon capture. And while those are important and they are to be solved, we still maintain that the first primary problem is what is known as particulate matter. Now, particulate matter is generally the stuff that you're going to visibly see. Now, that is step one. In our mind, there is enough scientific proof that you cannot solve the gases until we deal with the particulate matter. And that's what AirCure is about. That's our focus, is to radically improve or reduce the particulate matter before we get to the gas phase filtration. We believe in disruptive innovation. Disruptive means not just a new label, a new change, a little addition. We're talking about something that is going to be like candles to electricity, horse and cart to cars, film to digital, cell phones to smartphones. This is almost like setting fire to the existing in the hope of advancement. That's what's called disruptive. AirCure has a product matrix that we try and filter through all our products. They need to be original, they need to make a radical change, they need to be implementable, and they also need to show their worth. If you can't do that, you're going to fail. So every one of our products goes through this matrix. When it comes to air pollution control, they say there's no silver bullet. However, we have 3 revolutionary products that we think are going to make a substantial difference. The first is called a Cyclo duct, the second is Cyclo grit, and the third is Baghouse SC. The first 2 products are what we would call prefiltration, whereas the last product is a final filter, being the Baghouse. What is prefiltration? In military terms, it's like sending in the troops. So the army, the Marines, etc., they take the hits while the king is in his counting house counting out his money. So as in chess, all the pieces are expendable, except we've got to protect the king. We learned this years ago when we were developing filter systems for the mines. They had a terrible disease called silicosis, which is a lung disease from silica sand. And so we had this issue with really submicron sized particles getting down into the deeper parts of the lungs. So when you design a filter system, you start with the end in mind. And the beginning of the process is to start with what we call a HEPA filter. Now that is a really expensive filter, and understanding that this is a working mine, it's hard to imagine putting such an expensive filter. So what we needed to do, and we developed a multi-stage filter system where we had a pocket filter, a panel filter, and in front of that a fiberglass pad. These were then set up that they were the expendable parts while protecting the final filter. And we weren't getting the life out of the filters. So like all inventions, I have a wonderful saying that goes that necessity is the mother of all invention. So very rapidly we had to come up with a pre-filter. We didn't invent cyclonic separation. In fact, two scientists called Christian Huygens and Isaac Newton developed the idea of centrifugal force. And they said centrifugal force is the apparent outward force on a mass when it is rotated. So that's a bit above my pay grade. And if I explain this, I go back to my childhood. I'm giving my age away, but any of you who are my age would have gone to the Old Rand show in Johannesburg and found there was a ride, or if you could call it a ride, called the rotor, which was essentially a big steel cylinder, and you all marched in, sat up or stood upright back to the wall, and it would start to spin, which was really fun. And you would feel, as it went faster, you would feel the attraction onto the wall. And then they would take the floor away, which was highly amusing, and everyone thought it was funny as hell until somebody vomited. Then the audience thought that the rotor was amazing. The only cyclones that we could find at the time were tall vertical cyclones, and they were very tall. To duct to them and out of them was very complex. They had very little data in terms of pressure and efficiency, and they were really low to medium efficiency at best. But because we were looking for a solution in mines, in the tunnels, we just were disqualified on the first point. They were just too tall. Introducing the Cyclo duct. This is a horizontal inline cyclone. It can be made out of any material and made to any size. It's a South African product. It's our product, and we patented this in about 70 countries around the world. Very simply, you would remove a piece of ducting. This has three components. The one is the fixed blade. Now that creates the spin. So your downward fan would go through our blade. It would then create the centrifugal force towards the outside. And then you have a vortex finder right in the center, which would then allow the cleaner air to go through and the heavier particle to drop out. As you can see from the illustration, you'll see that it has a fixed blade. Now that blade has taken us something like 11 years to develop. And the pitch, the angle, the number of blades will determine the efficiency and the resistance that they create. So we can determine, by changing the blade, we can determine the efficiency and the pressure drop across it. The Cyclo duct has an interchangeable blade, which if you choose, you could increase the efficiency by selecting a 6, 8, 10 or 12 blade. This would then have control over the efficiency plus the resistance that we can select. So we have a selection chart whereby you can easily interchange one blade for another. Probably the best cyclone in the world. Now that's not just sales talk or me being boastful, but we've actually done extensive research around the world, and we've recognized that we have something absolutely unique in the Cyclo duct. We don't build cyclones, we build smart cyclones. We can size them to any size. We can make them out of various materials. We can make them adjustable so we can set the efficiency and the pressure resistance. They can be retrofitted to virtually any filter system on the market. And boy, have we tested them. We've tested them on CFD modeling. We've tested them in real life. And we have so many examples of just how effective these can be. CFD modeling is every product developer's dream. It's called computer fluid dynamic testing, and they essentially simulate what would happen in real life, and with a very high level and degree of accuracy. So you essentially would put your product into their test bay on computer, and then you would be able to recognize what particle size you're taking out, at what velocities and what pressures. And we've done up to now around about 35 different CFD modeling. First of all, we did it for testing, then we did it for product development, and now we highly suggested that before we make any product and sit on site and hold thumbs that it's going to work, is rather iron it out way beforehand and we get the efficiencies right before we manufacture a thing. As you'll see in this design, you could basically take a slice of ducting out, install this, but because this is 2 meters diameter and probably weighs about 6 tons, you would need a support structure. Some of the smaller ones you wouldn't, but in this case you would. Let me reiterate, no complex working parts, and every maintenance guy goes, yay! I coined a phrase, a filterless filter. Now, half of my staff thought I'd lost my mind the first time I revealed that statement, because we sell air filters. So nobody's ever going to accuse me of being a good businessman when I set fire to my filter business because I wanted to create the perfect cyclone. So why prefiltration? Well, very simply, you can save on expensive filters, you can reduce the wear and tear on all your downstream components, you can lower maintenance costs, increase the overall efficiency of any filter system you have, whether it's a baghouse, an electrostatic precipitator, or water scrubber. And potentially, if you create a new system, it could be greatly sized down. While my filter division wasn't so chuffed, the mines were, because we greatly reduced the amount of replacement air filters on the units underground. But we sold hundreds of the Cyclo ducts, and they became the leading practice in all the gold mine tipping areas. This is a shining example of just how effective these Cyclo ducts can be. The amount of dust that is dropping out here is phenomenal, and that essentially would have gone to the baghouse. We want to run through some of our latest projects with you. There's a company called Grinding Media South Africa, which is a subsidiary of Score Metals in Germiston, Johannesburg. They had in place a water scrubber which was using, if I'm right, about 1 million liters of water a month. They were using 500 kilowatt fans to drive the air. They had mud and slurry coming out the bottom. But the major problem they had was that they couldn't make the particulate matter legal emission standards. And we suggested they replace it with a baghouse, a modular baghouse. And in front of that, as a pre-filter, we installed these 1.5 meter diameter Cyclo ducts. By the morning, it was Raiders of the Lost Cart, and the amount of dust that had been dropped out by the cyclone surprised us all, but certainly we had to find an ulterior way of removing the dust after that. The first picture is the original stack coming out of the water scrubber. The one on the right is after the baghouse, and we went from a legal limit of 100 milligrams. During the process, it was reduced to 30 milligrams. we actually achieved 4. Sappi is a paper pulp manufacturer in KZN. They're all around the country, but they had 2 particular sites in the northern part of KZN. And they asked us a question: how far could we take cyclonic separation? It took 9 months of modeling to establish how we were going to use primarily cyclonic separation to remove about 96% of the particulate matter. And as this was the only filter between the boiler, the coal-fired boiler, and the stack, we needed to make sure that this was the most efficient cyclone we had ever made. In fact, it had 12 blades, and in order to assist the particles that had very little mass, the finer particles, we added a small suction to the base of the hoppers. We had very tight space constraints, and you'll see from the picture that we had 5 cyclones at the bottom and 2 at the top. That wasn't for just aesthetics, it was just because we couldn't fit them in any other way. As you'll see from the picture, below the Cyclo ducts you have a hopper where the heavy particles will drop, but we added that 20% suction, which was then taken to a small baghouse outside. The baghouse we installed was about 20% of what it would have been had we not had the Cyclo ducts. So this created the very first, I believe worldwide, where they have used prefiltration or cyclonic separation as the final filter. And we are so proud of the results. In fact, the legal limit was 250 milligrams per cubic meter, and we achieved no less than 160 milligrams per cubic meter. You'll see from the video how the stack emissions were absolutely immense, and post the installation you can see it's chalk and cheese. Smoke is not smoke, it's actually particulate matter. And you'll see from the screen that we have about 120 bulk bags, and these are 1.2 by 1.2 by 1.2. Each holds about 600 kilograms of the finest powder you've ever seen in your life. And that equates to about 13 tons of ash a day that is not going to the community. We had a chance meeting with a Dr. Norbert Seifert, and he was in the country as a doctor of engineering from Germany, and he was in the country for a couple of days as a consultant on an upgrade of an ESP for Sasol. And he'd heard about what we were doing with our Cyclo duct and asked for a meeting. And when we showed him what we'd been doing and what we'd achieved, he was quite intrigued and asked us if we had ever thought about making a bank of Cyclo ducts, in that there was no space. So we had a major space constraint, and he was looking for something that could slot in a rectangular duct. He then gave us 24 hours to come back with a design. And needless to say, we didn't sleep, but we came back with what we called 28 Cyclo ducts in a box. He was calling it a grit collector. A Cyclo duct is a single cyclone system, whereas the Cyclo grit is a bank of Cyclo ducts. Dr. Seifert firmly believed that if he could remove about 40% of what he called the grit, he believed that it would extend the efficiency or increase the efficiency of the overall ESP by removing some of the heavy particles. The brief to us was to remove about 40% of the total ash, as they only had 600 pascals additional pressure they could afford us on their existing ID fan. We, during the process of CFD modeling, worked out every possible efficiency we could grab out of the system and eventually landed on 56% efficient at only a pressure drop of 450 pascals. The dropout is unbelievable. Understanding that this is just the dropout underneath the cyclones, which is about 7 tons an hour, that is not going to the ESP. The net result of the combined action of the electrostatic precipitator upgrade, which was conducted by the main contractor, we were the subcontractor on the grit collector or the prefiltration stage. In fact, the legal limit was 50, and combined we achieved below 40 milligrams per cubic meter. We're so proud of these results that we published an article in the July 2023 Engineering News of all that we've been doing with cyclonic separation. The third and final product is a baghouse SC. Baghouses we've been making for the last 25 years. It's the way we are constructing them out of shipping containers that makes them seriously unique. Here's our latest video of just how they work. Repurposing shipping containers into baghouses, taking a single trip, almost brand new, no rusty old boxes, take them to our facility, we do all the cutting, grinding, welding, and turning them into baghouses before they leave the factory. They can then be placed onto road transport or rail transport and shipped to anywhere in the world. All the components, loose fans, filters, etc., go inside the shipping container for transporting. With the use of cranes, this becomes child's play on site to assemble. We have a patented Cyclo duct that goes onto the inlet, which is going to save and extend the life of all the filters inside. The dirty air in, the clean air leaves to a stack, and you've got the simplest, cheaper, faster, better. A baghouse in a box, literally like a piece of Lego. Cheaper, better, faster. Sometimes when people say cheaper, faster, I'm worried about quality. But with a shipping container, you won't get better. These things are made out of Corten steel. They are meant to be put on the high seas, 9 high fully laden. And for 20 to 25 years, they are bashed about. And this is the strongest thing that we could ever believe to be used as a baghouse. We have a vertical option, and as you'll see, these can be grouped together. The other main advantage is that all the parts get put inside for transporting and then put onto trucks and sent to site. The horizontal version can either use 6 or 12 meter shipping containers, and we can build the structure as large as you require. The first baghouse we converted from shipping containers dates back to 2015 for a company called Rock Fiber, who are a small to medium company who just didn't have the extra budget to meet the legal limits of their air pollution. I met with the owner, and at the time we threw an idea around. Could we make a baghouse out of shipping containers? He liked the idea, it suited his budget, and it just so happened that the legal limit had moved from 100 to 30 milligrams mid-project, and yet we had nothing to worry about because we actually achieved 1 milligram per cubic meter, and for the last 8 years they've met that legal limit every year. Here's the actual picture of the first baghouse that we ever made out of shipping containers. We published an article of our development in the Engineering News in July 2016, just to prove we were the first men on the moon to develop a baghouse from shipping containers. One of our latest projects was a very small vertical 8 cubic meter per second baghouse. And what was interesting was that this was taken off the truck and installed in virtually 1 day. When balancing the cost of air pollution control and trying to meet legal standards is really hard. We realized that air pollution control equipment is an absolute grudge purchase. Air pollution legislation is making it harder and harder for companies to get away with it. And the fear of closure or potential fines is a huge reality. But it's not the reason we believe you should do it. The real reason to do this is because we believe it's the right thing to do and because we can. We must change this picture. Blue skies for future generations. Thank you for hearing us out, and we look forward to being of assistance in your air pollution control. Thank you.